Good, good afternoon. Good afternoon. Thanks for coming here for the side event related to advances in space observation for tropical forest monitoring. Bonjour à tous pour l'événement sur l'avance dans les observations de la forêt dans le bassin de Congo. Our event, I will introduce our event and give you an overview of new assets in space related to forest monitoring. Then my colleague from GAF Fabian Ensler, will give you insight into a new Copernicus service related to tropical forests. Then Isabella from ONAC will tell you about the use of Earth observation in the monitoring of climate extreme events in Cameroon. Then we will move a little bit to the south to Mozambique, where Muri from the MRV unit will talk about forest monitoring and reporting related to RED Plus in Mozambique. And then we're moving on the other side of the ocean to Brazil, to Jean Ometo, who will talk about the national forest monitoring in Brazil. Thanks a lot for coming. I'm Frank Martin Seifert, coming from the European Space Agency. We are a space agency for 22 member states in Europe, covering all type of activities in space. I'm coming on from the Earth Observation Directorate, and we have a vision on how Earth observation can provide information on the planet, taking the pulse of our planet. What you see is are globes representing essential climate variables which we are collecting to give information on the actual status of the planet. How we are doing this, we are having 3 streams of satellite observation, meteorological satellite, which are as well related to climate. We have, you see it on the right side, we are having on to my right side, yeah. Sorry about that. You see the stream of research scientific satellites, and in the middle the Copernicus satellites, where we are in charge of the space segment of the European Copernicus program. Overall, ESA is looking to world-class Earth observation systems to develop within European partners, but as well international. With this, I would like to introduce you more to the individual satellites from out the Copernicus system. You see Sentinel-1. We have currently 1 operating unit in orbit. A second one will be launched in 3 weeks' time to complete again the system. Then we're having a high-resolution optical instrument, Sentinel-2. There are 3 Sentinels now in orbit. Sentinel 3 is the medium resolution imaging and radar and altimeter mission. 4 and 5 are related towards atmosphere, and 6 another altimeter mission. These are operational satellites providing an amount of 30 terabyte each day to to everybody, because the data and as well the derived products are free of charge. We are expanding the Copernicus system, and with respect to forestry, I would like to put attention towards 3 out of the 6. That is ROSE-L, an L-band radar, CHIME, an hyperspectral mission, and the land surface temperature, all interesting, related to the health and the status of forest globally. Other missions are related to CO2 or the cryosphere and radio altimeter and radiometer instruments. We are as well evolving the existing ones, giving them more capability, better resolution, to continue the stream of observations to allow us to understand better the climate in the coming decades. So what is it used for? I give you 2 examples. One from the optical, that is on Rondônia in Brazil, taken by Landsat 5 in '89. 20 years later, and over the same region, Sentinel-2, you see a lot more where the deforestation was spreading. And another 3 years later, where more or less the forest is almost gone, beside of one area there on the top right. Another possibility to look on developments within tropical forests, which is often hindered by clouds, is using radar satellite. And here we're using the Sentinel-1 system. And you see here within the Congo Basin, Central African Republic, how disturbances in the tropical rainforest advance. You see logging roads, and then from the logging roads, logging activities in the area. That doesn't mean that these are legal or illegal logging activity. We monitor that there's something going on. We are talking about advances in forest monitoring. I would like to put you to a new mission which is coming up. It will be launched in 2026, FLEX, and it's an imaging spectrometer to measure vegetation fluorescence. Or the biomass mission, a P-band radar, first P-band in space, which is measuring biomass as well in dense and rich biomass biomes. This will be foreseen to be launched next year in April. And related to biomass, we are already estimating biomass today. That is a project within our climate change initiative. Biomass maps from 2010 and annually from 2015 to 2021. The project is done in cooperation with JAXA, who are providing the L-band observations, which are very much appreciated. The cooperation is very much appreciated. Otherwise, we won't be able to get such good results. These annual maps are allowing to monitor it in a consistent way. We are still working on it to get it better and improve in the future. As you've seen with the biomass maps, it is about collaboration. We are collaborating with space agencies, but we are as well collaborating with countries supporting the monitoring of forests. That is in the Global Forest Observation Initiative, and that is to foster sustainable national forest monitoring systems within countries, providing support, guidelines, training, and helping the countries to advance their forest monitoring systems. And with this, I like to come back to our original agenda, and will hand over to Fabian to tell us more about products derived from the Sentinel-2 mission. Please, Fabian.
So we're going to wait for the presentation, but I can already start. There it is. Thank you. Thank you, Frank Martin, for the introduction and showing us all the satellites that are out there in space and on the upcoming missions that are very important to track biomass and as well estimate the biomass of the forest ecosystems. I just wanted to do a brief presentation on upcoming new Copernicus services. So Copernicus is the European Space Observation Program, and financed by the European Union. So there are several satellites, but not only satellites, there are as well services that are provided by Copernicus. And there's, for example, the land monitoring service. There's as well, for example, an emergency service where interested parties can request mapping on demand if you have flood events or fire events. So Copernicus is really a large Earth observation program, and today we will focus a bit on the products that will be available next year and that can be used for forest monitoring purposes. And specifically, I'm talking now on this Copernicus Global Land Cover and Tropical Forest Mapping and Monitoring project or activity. So if you go to the website of the Copernicus, there are various services as well. For example, on marine services, there are overall 6 different thematic themes. And the nice thing of these services is that all the data and the services, like, for example, Sentinel-2, Sentinel-1 data as well, are provided free of charge to everyone. So everyone who's interested in the data that is globally available for some of the services can download the data and use the data for their own purposes, as well for downstream services and for commercial applications as well. So the LCFM activity, it's actually a continuation of global land cover maps that were provided in the past years. They have a resolution of 100 meters. And now with let's say the better satellites with the higher resolution in kind of temporal resolution, but as well as spatial resolution, we can now map our land surface areas at 10-meter spatial resolution globally. And the idea of this LCFM project, what is the acronym or the working title, so to say, there's the idea on the one hand to continue the 100-meter products, but as well to improve the spatial resolution. So the consortium that is now producing these products, it's led by a Belgian company called Vito, and there we have GAFAG, where I'm working at, and other partners, GeoVol, GFZ, IGNFI, and IASA. So there's a big group of different companies involved. And here's just a first insight into the different activities. So on the one hand, we have a global land cover mapping activity, so that the 1A, 1B. And as well, we have the forest cover and change mapping, where you see under 2A and especially 2B, the tropical forest monitoring, which I will a bit highlight what to expect. So this is just a bit the structure of the consortium. It's about, let's say, just to give you a bit of insight, there are many components in such a big project and activity. And we at GAF, we are responsible for the tropical forest cover monitoring. So just jumping a bit through the slides. So if you have questions, you can come to me and ask, and then we can go into more details. But what to expect on the one hand side, we have annual information on land cover, but as well sub-annual information that will be available by this Copernicus service. And more on the right-hand side, you have the continuous products that build on the historical archive, so to say, on the land cover map at 100-meter resolution. So, and really the nice thing about it is that the 100-meter product and the 10-meter product on a global scale, as well for the land cover monitoring, but as well on the forest monitoring, they fit in spatial resolution and as well in the definitions that were applied. So you don't have a difference. If you look at a 10-meter product, you will have a similar land cover type at a 100-meter product. Speaking now a bit more on the tropical products that are specifically for RED Plus, for example, or for the new regulation on deforestation-free supply chains, the EUDR. So all these countries that are highlighted here in green, for these countries, there will be a tree cover information that is at 10 meter on the one hand side. We will have a tree cover density product that shows you the percentage coverage of tree canopy in a specific area. Here it's 10 by 10 meter, divided into 10 classes. And this will be made for the year 2020. So it's a tree cover density for 2020. And that is related a bit to the European regulation on deforestation-free products, the EUDR, because end of 2020 is the cutoff date where no more deforestation should happen, let's say, for agricultural expansion or use for products that are imported to the European Union. Interesting as well is there will be annual products at a 10-meter resolution, freely available for then the consecutive years, 2020 to 2026, as well freely available to everyone. And so there's as well a precise accuracy assessment, there's a validation. So, and as said, these 10-meter products, they fit nicely as well to the global 100-meter products. Just a bit on the timeline, what or when, what to be expected. We have here now in the reference year will be 2020, and then you can get the next updates within next year. And then, of course, the 2026 products will be released in 2027. But next year will be really kind of a milestone in providing the tree cover density and tree cover change products for the first years. So what we are looking at is the tree cover density here, just an example from Bolivia, where we have on the left-hand side a bit a larger area, and there's a small rectangle on the upper left with a zoom in, and on the right-hand side you see a clearing for agricultural use, but as well you see remaining small green stripes that are left trees for wind shelter to stop or to prevent soil erosion. So with a 10-meter resolution, you have really a nice granular detail on the tree cover in that area. As well important to mention is this tree cover and tree cover change product, it does not apply any forest definition. So it's really looking into trees inside and outside forest. There's no tree cover density threshold applied that is usually necessary to do a forest map. But you can then use actually the tree cover density information and the tree cover or the tree information to derive your own national forest cover maps. This is just another example from a cross-border region in Ecuador, Colombia. So this here we have a bit of a different type of, let's say, deforestation. So here we have larger clearings, but as well these larger clearings are very visible in the map, and as well you see then that in some areas you have a bit of opening of the canopy, and this tree cover density information is a kind of good and early indication where you have, or let's say where you have a high likelihood of forest degradation. A few other results, just to give you a first idea what to expect, what the tree cover density product will look like. This is actually from the Chaco region. Here you have a very high variability in different tree cover types. Here as well is a good example where you have clear, distinct openings for agricultural use, but as well smaller, the light green dots where you have sparser canopy cover. Here's as well a good example where you have different type of canopy cover, and as well here on the right-hand side, just to show a bit of a difference. And maybe to mention that the gray areas down there, these are areas that would be considered as no forests if you apply a forest definition. So this was a quick run through. I hope I could get your interest in these upcoming products and the Copernicus services. And yeah, reach out to us if you have any questions. And thank you.
Thank you, Fabian. And I give now the floor to Isabella from ONAC in Cameroon to present activities in the forest and overall in Cameroon. Thank you.
Thank you so much for giving me the floor. Here I'm going to present to you how we use observation data in the prediction and monitoring of climate extreme events in the National Observatory in Cameroon. The plan, I'll tell you a little bit of who we are, our mission, then the different extreme events, then how we use remote sensing and GIS application, then how we share our information that has been produced, then collaboration, maybe perspective, and then challenge, I don't know. Yeah. So here you find that the President of the Republic of Cameroon actually announced in 2007 during the Earth Summit in New York that he was going to create the National Observatory on Climate Change. And it was created in 2009. It took him a little bit of time up to 2015 where he actually created the National Observatory on Climate Change. And he actually had to make it operational in 2015 by appointing the board chair, the general manager, and his deputy. And the general manager is seated behind us. And then in 2019, he saw it that it was important to reorganize the National Observatory and give it some specific character for scientific research. And then it also made it autonomous, so ONAC can actually collaborate with other institutions. And then to 2023, he actually appointed the board members, which I am one of them as the staff representative. So you have as our main mission to monitor and assess the socioeconomic and environmental impact of climate change and to propose measures for prevention, adaptation, and or mitigation to these negative effects and risks associated to climate change. So you have this main mission being divided into two subtitles for adaptation and for mitigation. Then I go straight to the different extreme events that we monitor in the National Observatory. The first one is the drought. You find floods, and then second is droughts, and then we work a lot on landslides, erosion, sea level dynamic, and then the health sector. So these are some of the ones that are like hot extreme events that we monitor every day. And when we want to use the Earth observation data, there are things that we take into account. If we want to do something on urbanization, then we'll need a high resolution image like the one you find down. And then the first image is Sentinel, which is for national forest cover or earth observation dynamics. We use that one. And then the other one there is the global, which is MODIS. It's not very good when we want to work at national level. And then the position of Cameroon also make us to suffer a lot on cloud cover. So that's why you have this issue. So here you have the data cycle. What we do as the kitchen of the National Observatory, we collect the climate parameters from the visual stations that we have created. We collect this data from different platforms, from different satellites. Then we bring them out as statistics or as maps, and we share to the different departments depending on what they want to do. If it is for prediction of the climate condition for the next 10 days, we call it the 10 days alert. We will share it. And then we also have on the other side is the Earth observation that's analyzing the satellite image. So we get the satellite image, we have to treat every pixel, and then we bring out the results, especially to monitor our different resources and the land use. After we produce information, we need to share it so that it goes to the end user. Then these are the different channels that we use in sharing. We will drop the information in all the stakeholder, the administrations that are concerned. We also use our website where people visit. We also have platforms, social media platforms like LinkedIn, Facebook, Twitter, and WhatsApp. Then we also work with community radios. In fact, in community radios, I think is one of the options that is working very well, because when we produce the information, we share to these radios and they translate it into the local languages and they pass it through the radio. And then we have what we call the ONAC alert. You can use your phone. If you have an Android phone right now, you can download ONAC alert from Google Play. So this is one of the things that we predicted a landslide in 2019, and it happened 10 days after it happened 8 days after we predicted. We said that this area was of high risk of having this landslide because we were seeing the soil moisture was already saturated and man had tampered a lot with the land use. So they had changed the relief or the topography of the area. And when this happened, the Ngwashe, when it happened, we had 42 people died. So you can actually see with the satellite image the number of houses that were covered. So up was before and down is after the landslide. The other side also is Mbankolo is recent, and we also predicted there also we had improved in our predictions, where we actually said that the risk was very high between the 8th and to the 10th of October, and it happened the night of the 8th to the 9th. So there also we had 27 people who died. So when we passed information, we also receive feedbacks when floods or drought or landslides happen in the field. We receive through those same channels that we pass, like you find on the screen. Here it is very important because this is recent. It is inside the Decada alert of the 1st to the 10th of November. And on the feed, you actually had the situation of a landslide which was predicted. So there is the Foroke area, and this landslide occurred twice. It occurred in the morning, and then some engines were sent to remove the debris of the landslide, and while they were walking, another one occurred, covering them. So you actually see they are trying to remove some people from the ground who all passed away. So today we have 12 recorded, and they are still searching. This is a video. I don't know if we could play the video. Yeah. Here. Yeah. So that is the landslide. When it happened in the morning, people went to see how they were actually to remove what happened in the morning. And the second one actually happened in front of them. So you actually find it, and if you look very well, the caterpillar that was walking is being covered. So that's how we also succeeded in. There also, we are not only losing people, we are losing our resources like the forest, which is going. Maybe because of time, maybe we can. Yeah. So also here we have done the mapping of the forest cover loss with the help of the University of Maryland. And then I'm also going to present to you the process of constructing a bridge between Cameroon and Equatorial Guinea. This construction is to be financed by the African Development Bank, and how Earth observation helped us to change the game. Then we also have the monitoring of our islands and mangroves. And the last one is our water resources. For the results of the forest cover lost, we have 2000 as the baseline, and then the analysis show that Cameroon is having 0.3% of degradation rate according to this result. And you'll find that 70% of our national territory was covered by forest in 2000. So degradation while taking place. And this is a summary table that actually gives you the different percentages of the degradation rates per region in Cameroon. And according to the result, you find that the North region is the one that is having a higher degradation rate. Now you come to the bridge. The environmental impact assessment was already done before the National Observatory was consulted. And the red line just shows you where the bridge is supposed to be constructed. And then when the National Observatory came in, it is an area that we have been working. So we know that this area is very dynamic. The sea level is encroaching. And then we had to draw their attention on where they were proposing to construct this bridge, because we showed using the images that you find. Up to 2015, it was a little bit stable. And after 2015, you find that water was encroaching the land. And then you find here almost 130 meters 5 years after has been covered by water. So it means that in the next 10 years, the bridge will be hanging in water, and it will not be very useful for Cameroon and Equatorial Guinea. This is an island that was mangrove covered, and it is disappearing. We can find out with Earth observation, we are able to see how it has been evolving. Today, this area is just at 1,000 meters square with a few mangoes standing there. And then imagine living from 40,000 to 1,000 meters square. Here is our water resources. This is particular because in 2021, normally those who take care of the dam, it is the Lagdo Dam. It is energy production dam. So those who take care of the dam knows that in a normal routine at this period, we need to kind of leave water to go out so that the dam should not overflow. But with the coming of the climate change and the different dynamics of the climate parameters, they did not know that something else was going to happen. So the water that was left out and rain did not come back to fill, so the turbines could not turn to produce energy. So we had the situation where we had no energy in this locality. Here is collaboration. Our director is there. I'm sure he has his pen. If you are ready to sign with him, he will be signing with you. We sign at national levels, and then you have the different ministries. Here, the first image is with the Ministry of Agriculture, because we are able to produce them the information that they need, what we call the agricultural calendar. It tells them when to plant, when to harvest, depending on the climate situation that is in the forecast. On the other side, we have the ministry in charge of urban development and housing. There also, we have a collaboration with them. At international level, I saw somebody with ESA. I think everybody in ESA should be aware of ACRI-SA. It is the laboratory. We have a collaboration with them. I was trained in France by these people as well. Then the other side is FAO. With FAO, we have been able to mark the risk zone. Recently, we had high floods in the far north region. And with the results that we had with FAO, all the areas that we said were of very high risk were all flooded. And thousands of Cameroonians were like stranded. See, today the effect is there. And also, I think why we are here, we saw the letter that has reached the National Observatory where FAO is coming back to sign for other activities. The perspectives here are not many, but I think perspectives are like a shopping bag, a shopping list where you can buy if you are a friend of ONAC. We would like to see that the capacity of the laboratory is reinforced. We want to put in place an early warning system that functions normally, and also we want to develop a higher resolution digital elevation model for Cameroon. And we are expecting to be able to use high resolution satellite images. And then networking, you can also facilitate networking for the National Observatory. And we can join our hands for the search of funds. These are some of the challenges I will end here so that we don't waste so much time. Thank you so much.
Thank you, Isabella, for the insight into Cameroon forest monitoring, but as well related to management of extreme events. The landslide, what you showed in the video was heartbreaking. From that onwards, I would like to give the floor to Maurice Suarez from the MRV unit in Mozambique. Please, Maurice.
Thank you all. So my name is Muri Soares. I'm from the MRV unit in Mozambique. It's the unit responsible for monitoring forests and REDD+ since 2016. And I'll be talking a little bit about the work that we've been doing since our creation. So just a little bit of context into Mozambique. It's a country located in southeastern Africa, and it has a large proportion of forest, but also it's has one of the highest deforestation rates in the continent. And it's also characterized by dry forests, specifically miombo, which are particularly challenged to monitor using remote sensing. So to further detail, so miombo woodlands, they are open forests in general. They are deciduous, which means that they lose their leaves in the dry season, makes them hard. It changes their signature in the dry season, and also there's frequent wildfires, and these are not fires that kill the trees, but they are fires that change the dynamic and the spectral signature of the lands. And so again, it's another challenge for the monitoring using Earth observation. In addition, the main driver of deforestation in Mozambique is small scale shifting agriculture. Again, it's quite widespread. The fields are very small, and it's another challenge that we have. Also, the fields are then left in fallow, which regrows and can then be confused with forests again after a few years. So in terms of what led us to have developed this system for monitoring deforestation in Mozambique, first I would say it's the updating the national greenhouse gas inventory of the country, which the country has been developing over the years. The country also joined the FCPF, the Forest Carbon Partnership Facility emission reduction program in one of our provinces with the World Bank, and so this program had a very high threshold for monitoring the emissions from deforestation, and so it was necessary to create this system. We also wanted to be able to generate estimates of deforestation at provincial and district level for different management purposes. And again, in the last years, deforestation has become a key indicator for all rural development projects from the World Bank and others. And so all of these projects have as one of their objectives to reduce deforestation. So again, it was necessary to have a tool that would allow us to do so. So in terms of our annual forest monitoring tool, I won't go into too much detail, but we basically settled on using the Google Earth Engine platform, which is free to use. And as you may know, Mozambique is a developing country with not a lot of resources. We used Sentinel-2 imagery, again, because it was a system that was developed after 2016. And the Sentinel-2 imagery provides free images that are also of good resolution to monitor land use changes. We have a system that uses semi-automatic classification with a random forest classifier and thorough collection of training samples. And then once we have these annual deforestation maps, we have to conduct sample-based area estimation to have statistically robust estimates of area, especially for deforestation, which is quite a challenge in our ecosystem. And then the validation is done using a combination of images, including Planet, but also Sentinel-2 and freely available high-resolution images. So in the end, we are producing these maps of annual deforestation since 2017, and we plan on continuing to use them. We are using these maps, like I said, to generate annual statistics, but also to allow for the updating of our land use, cover change, and forestry estimates for the greenhouse gas inventory. All this information is available online. We have a web portal with deforestation statistics, and there you can get the statistics at national and provincial level, and then we also have statistics at district level in table format. It's accessible through our website from the MRV unit. We have also been working on monthly deforestation alerts. This is perhaps more applicable in Mozambique to protected areas because otherwise, land tenure allows for quite a lot of deforestation, and it's not so practical to have these alerts. But in case of conservation areas, it can be quite useful. Although sometimes there's also the challenge of actually, using this information in a timely manner. So in terms of the results, the outcomes that we have from this monitoring system, so I would say that the country was quite behind in the early 2010s, and so we produced our first FREL in 2018 with this system, and then we've been able to improve and monitor the Zambezia emissions reduction program with the FCPF. We've had 2 successfully validated and verified monitoring reports. We've also helped the country to produce its first and currently the second BUR, which both had REDD+ technical annexes, which are quite important for the country to access climate finance. Then I would like to talk a little bit our participatory MRV, which is a tool that we developed with the main driver being the emission reduction program from Zambezia, which is a program that the country receives payments, and then there is a benefit sharing plan that means that these payments have to be dispersed to the communities. And so it was important to have a tool that would allow us to share our maps with the communities. and also for us, it's important to understand what are the causes of the deforestation, because it's one thing to produce the maps and to have the statistics, but then to actually know what is going on, what are the drivers of this deforestation. And so we developed this tool that is quite simple to use. Our maps are available on an app, and you can just click on the polygon and fulfill a simple form. And we have done some training of local government, NGOs, and also local communities. In the program area, we've shared some tablets with the community members and let them collect some of these data points on their own, and it's been quite a success. So it's something that we're looking forward to implementing in the rest of the country. This is the dashboard, that's the publicly accessible dashboard that we've produced with all the verified deforestation points. So you can see there's a heavy emphasis on the Zambezia province, which is where we have the emission reduction program, but we also have points throughout the country. And in the bottom left, you can see that we have the main cause of the deforestation. You have shifting agriculture, which is the most important one. You also have commercial agriculture and charcoal or forest exploration. You also have what culture is practiced in case of agriculture deforestation. So in conclusion, I think Mozambique is a success story of creating a national team of MRV specialists that are from the country and that can allow continuous and stable monitoring of our forests. This monitoring system has allowed both the international greenhouse gas inventory, but also the jurisdictional REDD+ reporting to have numbers that are aligned and that share the same methodology. And this has been really useful for the country and has allowed for the reports that the country has been producing to pass both the UNFCCC technical reviews, but also independent validation and verification by these VVBs. So that's what I had today. You can visit our website on fnds.gov/MRV, and there you can find all our dashboards and web portals. So yeah, if you have any questions, I'll be happy to answer them later. Thank you.
Thank you, Muri. And last but not least, I would like to ask João Ometo from INPE, the Brazilian Space Agency, here to the floor and provide us information on the Brazilian National Forest Monitoring System. And it's a great honor to have him here, thinking about the road which will lead then from Baku to Belém in next year.
Thanks, Mark. Yeah, with a well-monitored forest, all right? So thank you very much, Martin. It's really a pleasure to be here, and I'm really glad that the presentations we had before. So I'm from the monitoring system. I'm more into the carbon part of it, which is my major focus. So this presentation was basically provided by the remote sensing department at INPE, which is it's a long-lasting effort in Brazil. So we've been monitoring, especially the Amazon deforestation, since late 80s. So and the point, it's going by itself. So I think we need. Oh, there we go. So I just gonna. Oh yeah, that's me, and that's Claudio information there. So the system, it's a wall-to-wall system monitoring clear-cut deforestation since like I said, late 80s. And those informations today are so the consistency of the monitoring series. It has 6.2 hectare. So that's the historical consistent of deforestation in the region. But we're providing data at 1 hectare's level for, especially for monitoring and policies for reducing deforestation. So the consistency of the methodology, especially related to the size of area, has provided a pretty nice strength. It goes by itself, but I'll keep going back. So it gives us the consistency of a long-term monitoring system at the specific basis, which is quite important. So now there's a lot of a visual interpretation for that, especially in terms of the complexity of defining the deforestation itself, but also on the consistent side. So we're moving a lot to a more automatic classification, but we're still having a lot of visual information. So the accuracy is pretty high because of that. And so this gives a lot of strength for this system. And so because of that, it's official information for several actions that Brazil takes. So we're moving along into a more of this systems of a data cube for actually using machine learning to be able to do more automated classification of that. So in a tropical forest, that's maybe is easy, sort of a easy step forward. But it's still the idea is to have a reference system, and the reference system is validated through visual interpretation a lot. So but we're moving into this because of the size. So Brazil is 8.5 million square kilometer, and the Amazon, the Brazilian Amazon that we monitor is about 5 million square kilometers. So is an area that has about 20% of its area already deforested, and those numbers determine a lot of effort to be able to keep track of the pace of deforestation. So moving into this is a technology that is being improved at INPE as well. So the different layers of information can help to validate also the deforestation and land, not only deforestation but land use change in general, a general perspective. And as I was saying, the Amazon is a critical region in the country for that, but also the savanna in Cerrado, which has a very, I think, as Mauricio was saying, the complexity of a savanna monitoring is different than the monitoring of uh, uh, a tropical forest, a green leaf forest. So we're also moving, as I mentioned, to a little bit of this machine learning. How we do is define patterns of reflectance, patterns of response of the system to different sort of a satellite information, and from that actually deriving patterns of land use change. So as I think most of the countries that's being represented here, the rate of changing the land cover in the country is still pretty high, and so the sort of having a more of automated system is pretty critical. So we all INPE not only does the annual deforestation monitoring, which is what we're just looking at, and this annual deforestation monitoring feeds the Brazilian national contribution, for instance, and feeds the Brazilian forest reference level for red and everything. So, but we also have systems that do the fast track monitoring for action on the ground in terms of curbing deforestation. So this system has a daily information in specific areas of the country to be able to the regulation system act in terms of reducing, especially illegal deforestation. But we don't classify the deforestation legal or illegal, but we just warn that deforestation is going on. All this is in an open system that is accessible from anywhere. It's in two languages, but you can access the latest information in terms of deforestation. So the system now it also includes burning scars, fires that it's going on. So there's a system that is associated to the deforestation now. We're kind of getting those information together. But in the same Terra Brasilis system, this can be accessed. At this point, we have Cerrado, the Cerrado region in Brazil, which is about 2.1 million square kilometers plus the Amazon. So that covers about 65% of the country that is right in that tool right now. But we're moving to have the whole country also represented in Terra Brasilis. This is it's just how we. Oh, this is the. Yeah, so this is the daily deforestation. So it's just showing a little bit what we can find at this platform in terms of area that is being deforested and in that specific resolution that I mentioned before. So we also started a few years ago doing a classification of the land use after the deforestation for the two biggest systems in the region in Brazil, which is Amazon and Cerrado, as I mentioned. So the Terra class, which is an effort from two institutions, with INPE and Embrapa, and also IBGE, which is not there. But the idea is to have a frequent monitoring of the land that is being used after deforestation itself. This is getting into the national communication of Brazil to on the I'll say the oh shit the the spreadsheet that actually defined the different emissions associated to land use. So that's a little bit of how the Amazon now it's occupy forests and other activities in the region. So we see that still there's a lot of moving going on, a lot of deforestation going on. We have the latest number that I'm going to show in a bit, but it's still a lot of action in the Cerrado as well. Most of Cerrado has been changed in terms of land cover. More than 50% is being it has lost its natural vegetation. Most of that is pasture. And the idea was to have this in a regular base produced. Now is every 2 years, but the idea is to have this in a more yearly basis. Those are the latest numbers. Sorry, I have some in Portuguese there, but so the latest numbers from the Amazon, which was just launched last year. So we are in a new and hopefully persistent trend in reducing deforestation. So we came from a very high deforestation in early 2000s, and that came down very steeply to 4,500 square kilometers per year. And then we went back up for several reasons. And then in the past 3 years, we're coming down again in terms of deforestation. So the monitor system is very important in terms of policy and in terms of action on the ground. So it's almost 44% reduction in the past 3 years. And that's what we do. We have this in a geographical distribution. So the municipalities at the ground can act in terms of defining who are responsible for the actions. So this is something that is provided for at federal level, but also at the local level. In Cerrado as well, there was being a reduction in deforestation. There is a very different land tenure between those two regions, but anyway, still has 25 reduction deforestation in Cerrado, and also we can map that. In this region, there's still a lot of agriculture expansion. So Brazil is one of the biggest soybean exporters, beef exporters, and all that. So a lot of this it's associated to the Cerrado region, and then we see that if we go to the north east part of the Cerrado, where the action is really going on still. And this reflects on emissions as well. So Brazil just launched here at COP his new NDC, and big part of the Brazilian emission profile is associated to to deforestation itself, to land use change, and so we see by those number that an action on reducing deforestation can really help on meeting Brazilian targets in terms of emissions. So yeah, so and this is just the whole suite of so we are a research institute, so science benefit a lot from the information that is produced in a regular basis from the institute. We have collaboration with the ESA, we have collaboration with other agencies a lot, and the information as much as we can gather, it's important. Brazil has its own satellite, but on top of that, we use a lot of provided information for that. One important aspect is that all information is available from the image itself to the analysis that is done. So this is all available, and since the early times. And this has changed a lot. So a lot of different actions in Brazil from different companies or NGOs providing also different views on deforestation, on the dynamic, which helps a lot on counteracting or, comparing or challenging the work that we do. I'm really glad that you mentioned about biomass. We are looking a lot on the biomass satellite coming out. We have two validation sites in the southern part of Brazil, and well, there's a lot of a collaboration that we are involved on, and we're pretty happy to be here. Thank you very much for the invitation, and thanks for listening.
So please just be careful. We can have one. So, thanks a lot, Jean, for your presentation. I ask now the speakers to the podium. And do you have any specific question? Then it's now the time to raise it.
Thank you. Thank you all for your presentation. It was very interesting. Perhaps I have a question for the last speaker for you, Jean. On the different monitoring system you were presenting, you talked about remote sensing. I wanted to know more about the monitoring of fire. Can you please tell me what are the satellites you are using in this system?
Yes, thanks. So the fire monitoring, it's a system that is also available. I would have to ask the person responsible for that, but I know that it's a constellation of satellites that is being used, and it's a daily monitoring as well. So and because of that, the program is called Queimadas, and you have all the information is based on Terra Brasilis as well, and you have it in English too. So the whole you can follow up what is going day to day in Brazil. Then you have the fire scars, you have the area burned, all that is provided. But I'll check and let you know which sort of satellite's been used. Thank you.
Other questions from the audience? Well, I have one for you, Fabian. When will these data sets be available? And I hope that will be as well part of the free and open data sets what we are used from Copernicus.
Yeah, so the planned timeline is that the data is available next year. So actually, I hope that when we meet maybe next year at the next COP in Belém, that we can then present as well the real data sets, so that you have a tree cover density over the tropical areas, but as well the global land cover data sets at 10-meter resolution, at least for the year 2020, and then in the continuous years, the other products will follow. But I have to say as well that there is a validation procedure involved, so that the products are really looked at the quality, and so there are different steps of quality checks. So let's say my best estimate is that mid of next year the first things will be released. Thank you.
Thank you. I also have a question for you and for Onak. You've discussed about the risk and the propagation of the information to the general public, and that's often the most difficult, trying to reach the people. But also, can you please tell us more about, in general, the reaction of the public? Will they tend to follow the recommendation, or not really? Will they still try to take the car to go to another place, or instead of staying at home, they will try to go and continue their life just as normal, although a risk alert has been issued?
Thank you very much for the question. I think it's first of all a very big challenge for the information to reach the end user, but ONAC has been working endlessly to see that this information reach the maximum users. We also have an activity where we compare those who are using our information and those who are not receiving. And you find that in our reports we have agricultural agri those in the agricultural sector who are using, they are like have maximized their production as compared to those who have no idea. And we also accept that it is a big challenge because even at the national level we have 300 community radios, but we are able to work only with less than 50 of them because we have been able to acquire funds to train this number that we have so as to be able to use the bulletins that we produce. It's a big challenge, but we think that those who are receiving are actually taking it into account. This morning, we also had the news of the North West, the governor of the West region of Cameroon, who is asking the authority to take into account what the National Observatory has predicted. It is the area where you had the landslide that we had a video. And so we said that the landslides are still of high risks in that area. So the governor this morning actually had a speech and called the attention of the authorities to take measures to avoid damage at maximum. So at least we are aware that those who are receiving and those who are using, they are benefiting. Thank you.
Pour l'audience français, on peut demander aussi en français.
Je pense qu'il y a mon DG qui voudra ajouter quelque chose.
Merci beaucoup. nous considérons que l'outil géomatique est pour nous une très grosse opportunité, que ce soit pour des questions. Do you hear French? I can do it in English. Bon, I will do it in English directly. Thank you. We think that the use of the geomatic tools is something very important for countries like Cameroon, for the adaptation and for the mitigation. I was very happy to see what is going on in Mozambique, and how it works. I was very happy for what was shared with us coming from Brazil. So there is a need to improve those potential, because the challenges are many. The necessity of using those possibilities for water resources, for the production of energy, for the sector of agriculture, and so on and so on. And for us, Cameroon, we think that at Frank knows that you have to talk on those things. You have to build concrete, practical activities which will help to find solutions in the different area. You take a country like Cameroon, you have 5 agroecological zones. You move from the Sudano-Sahelian area to the coastal area to the deep forest in the south and so on. You have to find solutions for all those problems, and the tools is there. The question is, how do we improve the capacities, the possibilities, so that we could achieve a mission which were given to us by the government, and to contribute in the socio-economical development of countries. Thank you very much.
Thank you, Dr. Amagu.
Thank you. But perhaps I have the mic, so I will ask another question to you, Mui. No trap at all. Earlier this year, one of my projects, the GDA Climate Resilience activity of the European Space Agency, worked over the domain of Mozambique to do biomass estimation using satellite data combined with a lot of in situ measurement, airborne measurement in Mozambique. Are you aware? Yes or no?
I'm not sure which one, because there have been a lot of biomass activities in Mozambique. So perhaps it's. I know that we have spoken with regarding the CCI biomass mapping initiative. There has also been other biomass mapping initiatives using LiDAR in
Yes.
Mozambique. So perhaps it's connected, but I think I would need to talk to you.
Thank you. I will try to reach out to you through Frank Martin
Thank
on
you.
this activity.
But I think also what the Monsieur was saying, I think one of the issues with how do we improve and how do we make these systems work, I think the big thing is ensuring continuity in the MRV teams, and I think that's a challenge that most developing countries have, because this is a highly technical work, and it's often not easy for the government to find the funds to finance these technical teams, and sometimes the funds come through a project and then the project ends and the team goes, and so I think that's the key challenge for developing countries, and then for the developed countries, to ensure that finance is done in a programmatic way, that it allows for these teams to continue working over time. That's the experience that I have from Mozambique, in that we were established in 2016, and 8 years on, we are still working. We still have the same team. The team has grown, but very few people have left. And so there's this institutional memory. There's all these processes that have been developed, and I think that's really the key.
Very quickly, just replying to your point, I think, and on what Mauricio said, I think it is really important to keep teams, and also to have really available information, being those data itself or systems itself. So the systems that I presented here, that I developed within the institute, which is a federal institute in Brazil, those are available. And what the institute tried to do is to provide training and capacity building for people that wants to use the systems. And sometimes, and I agree, they are a bit technical, so the teams need to be, kept and developing the knowledge within the teams. But I think that's a seed that need to be planted, and as long as the information is available and the systems are accessible, I think this is it's a process that it really does help in catalyzing new actions or having the information as you mentioned the importances of it.
Well, Muri, you were already anticipating a question which I was raising. What is, from your side, the most needed? And you said this continuity. I would like to listen as well to you. What would you see as the most needed for Cameroon?
Yeah.
You have it.
Yeah, thank you. I think one of the thing is mostly capacity building of the National Observatory at all level. We want to train more journalists or radio stations. We want to train the staffs of the National Observatory. I remember I was in Brazil for the IMPE and I was trained on Terra Amazon. It was a very good tool, and we have limited staffs who can really do the work in remote sensing. I've been trained in Accra. We really need this training. So capacity building, and also we have material, the tools that we have. They Some of them are not even able to run the different works that we are doing. So we need materials as well. And it's all about the capacity building, technical, technological, financially, that is needed. Thank you. I don't know, my boss has something.
Yep.
Yes.
Thank you.
It is a permanent process of learning by doing. If we start, she went to Brazil, she brought a lot of things, but how do we pass from the what she learned to the to inform, for example, in the north of Cameroon, when do you start to plant? When do you start to plant corn or I don't know, and so on? The, those are things in which we have to reinforce cooperation. And I think that I'm speaking once more to my friend. we need really to do concrete things on the field so that when the governments, I think the one of my country, when they find it, the information you are producing, an improvement, an amelioration of a certain number of things, for example, the yields, it is at that moment that they understand that they have to put money in that. But if up to a certain level, they are not feeling it, we need to start from somewhere and you have to make concrete things on the field.
Thanks a lot, Joseph. Jean, if you would have a wish, what should happen in the future within Brazil? You have a very advanced and a long history of the national of your national system. What would you like to see happening in the future?
Well, Martin, I think one. I think I would see the future. What based on what happened is that as much as you have available information, you can have actions on the ground. So I think this is a very important too. Being that on capacity building or being that on action for changing patterns. So this has really been proved essential to have available information. And on that, I think the actions by the ESA and Copernicus, for instance, open the data and open the information to free access. It's very really important. Which I would hope is that we get to a level that we reduce using technology and using the knowledge to reduce the change in the environment the way we're doing. So I really would have just love to see you all in Belém next year with reduced deforestation than we had this year and keeping reducing and more towards a more of a reasonable way of looking to the our systems, our forests and everything. So I think that'll be my wish for next year.
Thanks a lot. And related to open data for imaging systems, Brazil was a front runner before the US, and then Europe was jumping on this and providing these type of data free of charge. Thanks a lot for that. I think we heard a very interesting presentations on what is happening related to monitoring the national resources within countries related to forestry. We saw the actions related to extreme events in Cameroon, from the MRV unit in Mozambique, and from INPE with a long-standing reporting system. Let's hope that this type of information will lead to the right actions on the political level. And with this, I'm closing now the event and hope we're having some more discussions afterwards. Thanks a lot for coming. And thanks a lot for all the presenters.